Hi everyone. Let's do today's daily lead code challenge question. It's already 11:29 p.m. So I'll just set a timer for 15 minutes and look answer after 5 minutes. After 15 minutes. Okay. Um, Sorted subarray to be removed to make array sorted. So what is this question saying? Let's look at it. Given an integer array r, okay, remove a subarray can be empty from array such that the so given an integer array, remove a subarray from array such that the remaining elements in array are non-decreasing. It should be non-decreasing. It means it should be non-decreasing. It means increasing, right? 1 2 3 4 4. It can be 4 4 also. It is still not decreasing, but it cannot go from 4 to 3. So I need to remove a subarray from array. So from here, what can I remove? 1 2 3 10 4 4 to from 10 it should increase to 4. So I think I need to remove this. So return the length of the shortest subarray to remove. A subarray is a contiguous subsequence of the array. Okay, or maybe actually I could remove this, because if I remove this, then 1 2 3 3 5, it is still a uh, 1 2 3 3 5 is still a like sub array. So I could have removed either 10 4 2, or I could have removed 4 2 3 5, but since this is the shortest subarray, so this should be the answer, 10 4 2. Yeah, another correct solution would also be 3 10 4 as well, right? 1 2 2 3 5. So let's look at another solution, another question. From here, what can I move? I can see that 5 4 3 2 1. Oh my god, it is decreasing totally. I don't think I can do, because it is totally decreasing. So whatever I remove, it will always decrease. So I guess it will be 4 elements. We can skip a single element, and from 1 to 3 I don't have to remove anything because it is already non-decreasing. Wow, so how can I solve this question then? Interesting. I understand this was very easy to understand question, but the question is it easy to solve as well or not? Let's look at other examples. Let's create a random example. Okay, I think it is also about finding the longest going array. So for 26 6 23 6 2 4, so this is not possible at all, so I have to remove 23. 23 6, this is decreasing, this is totally decreasing. It is only increasing from 3 3 4 5. but this is still increasing, so I have to remove this and this both. Maybe I'll not be given input like this. I think I'll be given input where it is possible to remove just one subarray to make it descending. Or maybe I think in a question like this, answer would be, I guess, just remove everything, because here I cannot remove just one subarray to form an array, like that. So I think another intuition that came here is to be able to remove any subarray, what I mean is array, sorted array has to extend to the left or to the right, you know yeah, sorted array has to extend to the left or to the right. I mean the result sorted array's end position will always be either start or end, will always be the boundary position. If you understand, I mean, because if that is not the case, then so suppose sorted array does not start from, if sorted array does not start from this beginning, or if sorted array does not end in the end, then it is not possible. Because suppose if we cannot say that, okay, this mid one, this is the sorted array, right? Because if we have to say this is the sorted array, then it means that we have to delete sub arrays from the left and right. So we cannot the sorted array, the result array i.e. result sorted array, what I mean is cannot be the middle array, because then we would have to remove two sub arrays. On the left and the right. So that is one intuition that I got. Oh my god, I have to explain it right by writing so much. I could have written to the point, but it's okay for now. So this is one intuition. Means, so can I use this intuition? Like I have to go from left or right. So maybe I can start from the left first and see. Okay, from 23, 6 to 4. Okay, it is not possible, right? From if I go from the left, it is not possible to create a sorted array when I go from the left. So what if I go from the right, then is it possible? Because if I go from the left, I can only create one subarray. I can only create length at most 1. Sorted array of length 1, right? But what if I go from the right one? From the right one also I can only create sorted array of length 1 here as well for this one. So it means that the answer will be 1. Let's look at this example. So for this one, if I go from the left into 1 2 3, it is increasing 3 10, it is increasing 4, it is not increasing now. So it means that 1 2 3 10 4. So if that is the case, then anyway, it means that 1 2 3 10, right? So there are 3 elements already. I mean, I've already got 4. Longest array will be already for 4, you know. And then from right, if I go, then it will be 2 3 5, which is 3. So how will I know, like, is it like a dynamic programming or something? Because do I have to find all the solutions? That is a brute force solution, you know. I know that, okay, 1 2 3 10, I can look at all the other numbers to see if I find a number that is greater than 10. Or if I do not find a number that is greater than 10 but find a number that is greater than 3, then that is also okay. 4. But if I find a number greater than 3 but other numbers would also be greater than 4, you know. But no, only this is the array that is greater than, actually. I just want to look at the solution at this point. I'm sorry, guys. But this is similar approach. I also went from left to right and then right to left. But I could not move forward from there, and I think they are moved forward from there. So you see, you can imagine starting from the right side of the array, there is a line dividing the sorted section from the unsorted section, left side. For example, so all this will 0 0 0 0 and this will be 1 1 1. So 1 1 1% is sorted. We can actually perform a binary search on the sorted section. So find the earliest point on the right where any sorted left section can merge with it. This allows us to find the earliest point on the right where any sorted left section can merge, minimizing the middle subarray that needs to be removed. However, you can optimize this further, replacing binary search with a more efficient two-pointer approach. I didn't understand. Is that the unsorted yellow region must always be part of the removed subarray since it breaks the sorted array. Yeah, that's true. This should always be, so 1 2 3 10 4 2 3 5, right? So 1 2 3 10 4 2 3 5, so it means 1 2 3 10 4. So this should always be a part of the subarray because it breaks it. In other words, the remaining sorted array will always be a prefix of the blue subarray. And the first element of the sub index followed by a suffix. Okay, I will understand until 5 minutes. Okay. In other words, the remaining sorted array will always be a prefix of the blue subarray from the first element up to the sum index, followed by a suffix of the green subarray from the last element down to sum index. Will always be a prefix of the blue subarray from the first element of the up to sum index, followed by a suffix of the green array from the last element down to sum index. To consider all possibilities, use two pointers left and right. The pointers represent the prefix of the blue array. So it will be 1 2 3 10 and 2 3 5, right? So it means that it will the point that should be deleted will always be say 10 4 or 10 4 2. So what they mean is, so since these two are sorted and this one is the one that is breaking the order, right? So it means that I will always start from somewhere around this part, and J will always end from somewhere around this part. So here in this case, I is for this first scenario, and J is this one. This is I and this is J. Hmm. Okay, yeah. They're trying to find length of all removed subarray possible and getting the minimum of everything and returning instruction last. Okay, yeah, thank you so much everyone.